Hey, this is Mr. Coker, and I am going to talk about similarity and proportion. Is that exciting? I hope that's exciting because we have similarity and proportion. Okay, so first of all, let me talk about what similarity is. So, when we're talking about similarity with two figures, we mean that they have the same shape but different sizes. And later on in this class, we will talk about similar triangles. But right now, we're talking about just generally similar polygons or objects. Now, these two are quadrilaterals. And if you look at each one of them, they, each one has some of it, either two or three of the side of their sides measured out, and they have numbers. Now, if we have similar quadrilaterals or similar objects as we have here, what that means is that each corresponding side is in proportion with one another. And our goal on this assignment or this problem is going to be to find the scale factor. Now I'm going to be putting it from smallest to biggest. I'll show you in a minute. So what I want to do is, first of all, look at what corresponding sides we know about. So we know this left-hand side of the quadrilaterals, of each quadrilateral, we know one is 32 and one is 40. We also we know that one of them is 31.6 and one is 39.5. Now, on this one, we know this is 25. We do not know up here. We don't know. And that's okay. We only need to know one of the two, or one of the two of the sides, two corresponding sides, one from each one. I said that wrong. But we need to know corresponding sides from each triangle. Now, I can either use 32 and 40, or I can use 31.6 and 39.5. I'm going to use the one that does not have decimals just to make it easier. So I'm going to use 32 and 40. We can agree, can't we? 32 and 40 are corresponding sides. The left side of this quadrilateral, the left side of this quadrilateral. So I'm going to take the numbers 32 and 40 and write it as a fraction. You see that? It's written as a fraction. 32 over 40. Now I'm going to reduce the fraction. Now, reducing the fraction, in this case, we could do it in a couple of ways. We could do it by saying, what's the largest number that goes into both 32 and 40, which in this case is 8, and divide each side, the top and the bottom numerator by 8 and the denominator by 8. You can also just use a calculator. I would suggest, if you have it, use a calculator. It will reduce to 4 over 5. If we reduce the fraction, it becomes 4 over 5. Now, almost done. Now what I'll do is I'm going to write this as a scale factor. Remember, I said I'm going to put the smallest number first. I'm just going to do that on all the examples, just for consistency. So what I'm going to do is I'm going to take the 4 and 5, and I'm going to write it in this manner. 4 colon 5. That means 4 do 5. That means 4 to 5. That's what it means. Okay? I wrote it out in words so that you can know when I say 4 to 5, I don't mean the number 2. I mean 4 to 5. This is the scale factor. So I hope that makes sense. I'm going to do one more example. Pause it if you need to, because I'm going to erase this dirty board. Good. Okay, so the next one I'm going to do is I'm going to do, I believe, a triangle. So I'm going to do one. I say a triangle. I'm going to do 2 triangles. Okay. So now I have 2 triangles. One of them we have all 3 sides. One of them we only have 2. First thing I want to point out, now I didn't do this on the first one, but I'm going to do it on this one. This 21, for this type of problem, we can ignore it. We're just finding the scale factor. Since we don't have a measurement for the bottom of this triangle, we don't need to worry about the bottom of the other triangle. Now again, we have 2 sides that for each, now 2 sides for each of the triangles that we can compare. Also, again, remember, don't use 30 and 25 and 15, 18 and 15. We want to do, I really, like you suggest, to stay consistent. Here's what I'm going to do. I'm going to use the 30 and the 18 this time. Okay? Just because last time I used left, left, I'm going to use left, left again. Now we can use right and right. We can use 25 and 15. It is okay if we do. I just want to say, but I'm just going to stay consistent. Now I'm going to do 30 over 18. Okay? Again, 25 over 15 would do the same thing. It will give you the same answer. So 30 over 18. We can reduce that. Again, either find the largest factor of both 30 and 18 and divide by that, which is 6, or just use a calculator. If you, either way of doing it will give you this result. 5 over 3. Okay? Now I'm going to write it as a scale factor. Remember what I said before. I'm going to do it smallest to largest. So instead of writing 5 to 3, I'm going to write 3 to 5. And that's it. Now I said okay, that's it. Last thing, I said that I'm going to do the left and left just to be consistent. What if I was like, no, I don't want to be consistent. I want to do right and right. So let's say that I decided to do 25 and 15. 25 over 15. Again, if you put this in a calculator, or if you just find the largest common factor, the greatest common factor of 25 and 15, it's 5. Divide each side by the top and bottom by 5. You get, or put it in a calculator, you get 5 over 3. Again, 3 to 5. My point here is that as long as we pick sides that correspond to each other, it does not matter which side we pick. We have to stay consistent and do left, left, or right, right. Okay? Or if we had a bottom, if we had the number here, we could do like that. We could also do that, but we don't have that. It would be what, 42? No. Over now. It would be 35. It would be 35 here. So, but we're not having you find that right now. So, the next video, I'll talk about finding a missing number. Notice how this one, it's missing. So in the next video, I'll talk about how to find a missing number. Okay? Thanks for watching. Hopefully that was super duper informative and exciting. I think it was informative. It just might not have been exciting. But maybe it was.